Hello, everybody. In this meeting, I'm going to be talking about timers. So like in the first video I sent connecting, I'm already connected and I've got my main routine up, which is empty, as you can see. So now my goal is to use a timer within a program, and I'm going to show you guys how to create timers in your controller tags. You're going to create them. They're digital input-output devices. And I'm going to create one, and then I'm going to show you how to put it in the program, and then I'm going to show you what you can do with timers. So what I'm going to do first is I'm going to go to my controller tags over here on the left, and you'll see my local inputs, outputs, and then you'll see a tab down here at the bottom, one that says monitor tags and one that says edit tags. If I click on this edit tags, you'll notice you'll see a blank spot down here in the little spreadsheet above. So if I click on one of these blank spots, preferably data type, which is where I'm going to start, if I click there, you'll see this box with 3 dots. Click on that box, and you can either type in timer, and it'll come up, or you can actually just search for it. Once I get timer highlighted, you can either click OK, and that will create one timer for you, if that's what you want to do. But what I like to do is I like to create multiple timers so I can have them to use in the program, because you can't use the same timer. I mean, you can use the same timer for multiple functions, but sometimes you might need 2 separate timers for 2 different functions. So this dimension 0 here, the dim 0, if I bump that number up to 5 and hit OK, that will actually create 5 timers. See how it says timer 5? It'll create 5 separate timers for me, timer 0 through timer 4. So I'm going to hit OK, and now you see it here, but it needs a name. So I'm just going to give it a name of delay timer. Anytime you hit the space button, it'll automatically put this underscore in here. So if I click down here just to click off of it, now it has saved my timer. So if I expand that, you'll see timer 0 through timer 4, and I have 5 different timers. You just want to look at the parameters. You can expand them, and then you can see actually some of their, one that says preset, accumulation enabled, TT, and then done. The main focus of what we're going to be doing and adding into the program, we'll worry about the preset and the done, but timer done obviously means it's done timing on a preset time condition. So go back into your main routine, and now we have access to timers to use. So I'm going to tell you what I want done, and then I'm going to do it. So I want switch 1 to turn on a light, and then after 5 seconds, I want a second light to come on. So light 2 to come on after 5 seconds. So switch 1 will turn on light 1 and light 2, but with a 5-second delay between them. So we'll use a timer on delay for that function, was what we're covering. So I'm going to go ahead and add a rung, and you'll see this pop up. I want switch 1, so go back into my addresses, drop down, go to inputs, click on data, and 0, then switch 1 pops up. Now I want to turn on light 1, so I put my OTE, then I find the address for light 1, which is in our outputs, data 0 for light 1. Now after 5 seconds, I want light 2 to come on. So what I'm going to need to do is I actually have to add another rung to the program. When I add that rung, I'm going to go ahead. You can use this light as an input device on your second rung. I'll show you how to do that. Click your Examine On, or your XIC, as it's more commonly known. Remember how you can click and drag the addresses? So if I highlight the address and then I click the address and drag it down, not the device or the description, the address, now that light will act as an input device to energize the next thing, which is going to be our timer. So if you want to add a timer into a logic program, you just go up here to your tabs. See how you're on favorites now for your rungs, branches, and XIOs, XICs, and such. If I click on this timer counter tab, notice you'll see TON, TOF, RTO, RES, all this stuff. What we're going to use is a timer on delay. So I'm just going to click on that. Now you'll see some blank parameters with question marks. So we got to give the timer an address just like we do everything else. So on the timer, double click that question mark. Now we got to find the timer we want to put here. Now you're only going to see timers because we're on a timer. So if we want to give that an address, we're just going to expand this, and then you'll see timer 0 through timer 4. We're going to go ahead and give this an address of timer 0. So just double click on timer 0, click off of it. Now this is delay timer 0. So timer on delays in a PLC program, especially Allen Bradley PLC programs, run in thousandths of seconds. So if I want this to be a 5-second preset delay, I need to put 5,000 in here. So I can go ahead and assign that now. I'm just going to type in 5,000 on the preset, just click off of it. Now we have a 5-second delay timer in place to turn on light 2. So how do we do that? Well, we're going to have to go back and add another rung. And then we need a way for this timer to energize light 2. So we go back over here to our favorites, and we're going to add in another XIC. And we're going to go ahead and add an OTE in for light 2. So let's go ahead and find light 2 here to give that the address for this output. And it's going to be address 1 for light 2. So there we are. We're good. But over here, how do we get this timer to energize this bit? What address do we need to give this? So since we're using delay timer 0 on our timer on delay, what we need to do is when this is energized and enabled, this energize is going to be green, but this DN stands for done. That means it's done counting. So when it reaches 5 seconds on your ACCUM, this is going to energize. So what we need to do is put the done bit down here on this XIC. So I'm going to double click on this question mark. Then I'm going to find delay timer 0 and then expand it and then find that delay timer 0 dot DN bit in there. So hit this drop down. You can see your delay timers are there. Expand it. Now you see delay timer 0. We don't just want to put delay timer 0 there because that doesn't do anything for us. So you expand a delay timer 0, and then you can move this over so you can actually see what they are. Always highlight over here like this, hover, and then click and drag. That way you can actually see what your addresses are. We're looking for .dn, which is right here. Delay timer 0 .dn. That'll be when it's done counting to 5, it will be energized. So we'll just click on that, assign it, and now everything is addressed. Now that everything is addressed, we can finalize our edits. So we're just going to go right up here to this big green arrow, hit yes. Now everything has addresses, 0 errors, 0 warnings. We can close that. So now if I turn on switch 1, light 1 will come on. And then when light 1 comes on, this input bit will energize because it has the same address as light 1, thus energizing the timer enable, which will start the count to 5. And when it reaches 5, our done bit here will become energized, energizing the done bit here, the XIC, and thus energizing light 2. So I'm getting ready to turn on switch 1. Watch what happens. Light 1 will turn green instantly. Your L1 down here will turn green because your output's energized. This will start counting, and then after 5 seconds, your delay timer.dn will energize, turning on light 2. So on the physical hardware, I'll flip switch 1, light 1 will come on, and then after 5 seconds, light 2 will come on. You can actually see it in logic. Here we go. And there you go. So what happened was we had that 5-second delay, and then light 2 turned on. If I turn off switch 1, it'll de-energize light 1, and your timer will reset. See what happened? Our accumulation went back down to 0, and everything went back off. So I'm going to turn switch 1 on again, and just pay attention to the timer counting, and watch what happens when it reaches 5. This L2 will energize. and there's our 5-second delay. So in a program, that's exactly what would happen. You can use a timer on delay to create a delay to get another output. That way they don't come on at the same time. Practical applications, this might be something where you want one motor to start up and get a good pressure build before another motor kicks on and keeps an assembly line or a fan going. But yeah, this is just a practical example of how to create a digital timer on delay and then what it can be used for and exactly what they are used for. All right, I hope this was helpful, guys. Have a great day.